Hello and welcome to add-on. So, the question is obtain Fourier series for the function fx is equal to sin x in an interval 0 to pi and 0 in an interval pi to 2 pi and further deduce the sum series. So, to solve this question हमें याद होना चाहिए formula for Fourier series expansion, which is f of x is equal to a naught upon 2 plus summation n is equal to 1 to infinity an cos nx plus summation n from 1 to infinity bn sin nx. This is for interval 0 to 2 pi, where a naught is given by 1 upon pi integration 0 to 2 pi f of x dx. An is given by 1 upon pi integration 0 to 2 pi f of x cos nx dx, and bn is given by 1 upon pi integration 0 to 2 pi f of x sin nx dx. Now हमें फाइनल फॉरियर सीरीज एक्सपेंशन इस फॉर्म में चाहिए, जिसके लिए हमें a नॉट a n एंड b n की वैल्यू फाइंड आउट करनी है. मार्क दिस एज इक्वेशन 1 एंड नाउ फाइंड द वैल्यू फॉर a नॉट. a नॉट इज 1 अपॉन पाई इंटीग्रेशन 0 to 2 pi f of x dx. नाउ fx की वैल्यू दो इंटरवल्स में डिवाइडेड है, सो हम इंटीग्रेशन दो इंटरवल्स में लेंगे. इट इज 1 अपॉन पाई इंटीग्रेशन 0 to pi f of x dx plus integration pi to 2 pi f of x dx, which is equal to 1 upon pi integration 0 to pi f of x की वैल्यू in an interval 0 to pi is sin x, so it is sin x dx, and in interval pi to 2 pi it is 0, so ये पूरा पार्ट 0 हो जाएगा. This gives a naught is equal to 1 upon pi integration 0 to pi sin x dx. Now integration of sin x is minus cos x and it is 1 upon pi. Limit is from 0 to pi, so it will be 1 upon pi. Take minus outside. Now put the limit cos pi minus cos 0. Now to solve this हमें पता होना चाहिए cos pi value is minus 1 and cos 0 is equal to 1. So using this, a naught is finally minus 1 upon pi minus 1 is equal to minus 1 upon pi multiply minus 2, minus minus plus, it is 2 upon pi. So a naught is equal to 2 upon pi. Now for an, formula is 1 upon pi integration 0 to 2 pi f of x cos nx dx. इसको भी दो पार्ट्स में ब्रेक करेंगे. इट इज 1 अपॉन पाई इंटीग्रेशन 0 to pi f of x cos nx dx प्लस इंटीग्रेशन pi to 2 pi f of x cos nx dx, जिसमें फंक्शन की वैल्यू इन pi to 2 pi इज 0, सो ये वाला पूरा पार्ट हो जाएगा 0. तो इसे हम लिख सकते हैं 1 अपॉन पाई इंटीग्रेशन 0 to pi fx की वैल्यू इन 0 to pi was sin x, so it is sin x cos nx dx. Now to solve this integration हमें trigonometric identity पता होनी चाहिए, that is sin a sin b, it is sin a and cos b. So the identity is for sin a cos b is equal to sin a plus b plus sin a minus b divided by 2. So using this identity हम इसे simplify करेंगे. It is 1 upon pi integration 0 to pi 1 upon 2 in bracket sin a plus b, that is x plus nx, plus sin a minus b, that is x minus nx, and divided by 2 with dx. It is a and it is b. Now simplifying this further, it is equal to 1 upon 2 pi, take 1 upon 2 outside, integration 0 to pi sin 1 plus nx plus sin 1 minus nx dx. Now take the integration of sine. Integration of sine is minus cos. It is 1 upon 2 pi minus cos 1 plus nx divided by 1 plus n plus minus cos 1 plus nx divided by 1 minus n. It is not plus, it is minus. So ये हो जाएगा 1 upon 2 pi minus cos 1 plus nx divided by 1 plus n plus minus minus cos 1 minus nx divided by 1 minus n. Take minus common, it is minus 1 upon 2 pi in bracket cos 1 plus nx divided by 1 plus n minus cos 1 minus nx divided by 1 minus n and limit थी 0 to pi. So now put the limits. It is minus 1 upon 2 pi. Take the upper limit cos 1 plus n pi divided by 1 plus n minus cos, it is plus since हमने minus बाहर ले लिया है, so it is plus cos 1 minus n pi divided by 1 minus n. Now put the lower limit minus cos 1 plus n multiplies 0 is 0 divided by 1 plus n plus cos 0 divided by 1 minus n. Now हमें पता होना चाहिए that cos of n pi is equal to minus 1 raised to the power n. अब हमारे पास cos क्या है? cos 1 plus n pi. So ये क्या होगा? minus 1 raised to the power 1 plus n, जिसको हम लिख सकते हैं minus 1 raised to the power 1 multiply minus 1 raised to the power n, and minus 1 raised to the power 1 is minus 1. So it is minus में minus 1 raised to the power n. Similarly, cos 1 minus n pi is minus 1 raised to the power 1 minus n, which is equal to minus 1 raised to the power 1 multiply minus 1 raised to the power minus n, जिसको हम लिख सकते हैं minus 1 raised to the power minus n, जिसको हम further लिख सकते हैं minus 1 raised to the power n. Since minus 1 raised to the power minus 1 is equal to 1 upon minus 1, which is also equal to minus 1. So finally दोनों के ही आंसर सेम आएंगे, that is minus 1 raised to the power n. So ये हो जाएगा minus 1 upon 2 pi cos 1 plus n pi is minus 1 raised to the power n divided by 1 plus n plus में minus 1 raised to the power n divided by 1 minus n, and cos 0 is 1, so it is 1 upon 1 plus n plus 1 upon 1 minus n. Now it is 1 upon 2 pi minus 1 upon 2 pi. Take 1 plus n term common, it is minus 1 raised to the power n divided by 1 plus n. इसमें से आएगा minus 1 upon 1 plus n. दोनों का डिनोमिनेटर सेम है, एक साथ लेंगे इन्हें. Now plus minus 1 raised to the power n divided by 1 minus n, and here there is a minus outside, so ये वाली term minus में आ जाएगी, so it is minus 1 upon 1 minus n. Now इसको हम लिख सकते हैं minus 1 upon 2 pi. Take minus common, it is minus 1 raised to the power n plus 1 upon 1 plus n. Take minus common, it is minus 1 raised to the power n plus 1 upon 1 minus n. Since दोनों का denominator same है, again take minus common, so minus plus it is 1 upon 2 pi. In bracket it remains minus 1 raised to the power n plus divided by 1 plus n minus 1 raised to the power n plus 1 divided by 1 minus n. Since हमने minus common ले लिया था, तो this will be plus. Now take the numerator common, so it is minus 1 raised to the power n plus 1 divided by 2 pi. In bracket it is 1 upon 1 plus n plus 1 upon 1 minus n, जिसको simplify करेंगे it is minus 1 raised to the power n plus 1 divided by 2 pi. On simplification it is 1 minus n plus 1 plus n divided by 1 plus n multiply 1 minus n. So an is equal to finally minus 1 raised to the power n plus 1 divided by 2 pi in bracket minus n से n cancel. It is 2 upon 1 plus n. 1 minus n is 1 square minus n square. Since a plus b and a minus b form gives a square minus b square. So a square minus b square, that is 1 square minus n square. It is, now इसमें 2 से 2 cancel हो जाएगा. Remaining is minus 1 raised to the power n plus 1 divided by pi in bracket 1 upon 1 minus n square. Now an जब exist करेगा when n is not equal to 1. Okay, अगर n is equal to 1 होगा so an will be not defined. Since denominator क्या होगा 0 हो जाएगा. So n is not equal to 1. But अगर n is equal to 1 है तो an क्या होगा? So for n is equal to 1, an क्या होता है? It is 1 upon pi integration 0 to 2 pi f of x cos nx dx. अगर n 1 है that is a 1 है so it is 1 upon pi integration 0 to 2 pi f of x was sin x in an interval 0 to pi and cos nx के प्लेस पे क्या आएगा cos x since n क्या हो गया है 1 cos x dx n plus interval pi to 2 pi this whole term is 0 so इसको लेने की कोई ज़रूरत ही नहीं है so हमारे पास आएगा finally a1 is equal to 1 upon pi integration 0 to pi sin x cos x dx. Now we need to use a trigonometric identity जो होती है 2 sin x cos x is equal to sin 2x. Now हमारे पास है sin x cos x. So ये क्या हो जाएगा sin x cos x is equal to sin 2x divided by 2. So using this हमारे पास आ जाएगा a1 is equal to 1 upon pi integration 0 to pi sin 2x divided by 2 dx which is equal to 1 upon 2 pi integration of sin 2x is minus cos 2x divided by 2 and limit is from 0 to pi. This gives a1 is equal to 1 upon 2 pi, take minus common. Now put the limit cos 2 pi minus cos 0 divided by 2 which is equal to minus 1 upon 4 pi. Now cos 2 pi is minus 1 raised to the power 2 minus cos 0 is 1. So it is equal to minus 1 upon 4 pi minus 1 raised to the power 2 is 1, that is 1 minus 1. So it is 0. This implies a1 is equal to 0. Now we need to find bn which is given by 1 upon pi integration 0 to 2 pi f of x sin nx dx. Again हमें interval break करना है so it is 1 upon pi integration 0 to pi f of x sin nx dx plus integration pi to 2 pi f of x sin nx dx. Now ये वाला पार्ट क्या हो जाएगा 0 since function की वैल्यू pi to 2 pi में क्या है 0. So it is equal to 1 upon pi integration 0 to pi के बीच में फंक्शन की वैल्यू थी sin x multiply sin nx dx. Now to solve this we again need to use trigonometric identity जो होती है sin a sin b is equal to 1 upon 2 cos a minus b minus cos a plus b. So using this हम इसे लिख सकते हैं 1 upon pi integration 0 to pi 1 upon 2 cos a minus b that is x minus nx. So it is 1 minus n, take x outside, minus cos a plus b that is 1 plus n x and dx. Now इसको हम लिख सकते हैं 1 upon 2 pi integration 0 to pi cos 1 minus nx minus cos 1 plus nx dx. अब इसका इंटीग्रेशन क्या होता है इंटीग्रेशन ऑफ cos is sin so it is 1 upon 2 pi take integration for cos it is sin 1 minus nx divided by 1 minus n minus integration again sin 1 minus it is 1 plus nx divided by 1 plus n, and limit is from 0 to pi. Now put the limit, it is 1 upon 2 pi. For upper limit, sine 1 minus n pi divided by 1 minus n minus sine 1 plus n pi divided by 1 plus n, minus put the lower limit, sine 0 divided by 1 minus n minus sine 0 divided by 1 minus n. Since 0 है so x की multiply 1 minus n से 0 ही आएगी, so it is overall sine 0. Now solve this further, जिसके लिए हमें पता होना चाहिए that sine of n pi is equal to 0 and sine of 0 is also equal to 0. So ये हो जाएगा 1 upon 2 pi sine 1 minus n pi divided by 1 minus n minus sine 1 plus n pi divided by 1 plus n minus this whole term is 0. Since हमें पता है कि sin n pi क्या होता है 0 और sin 1 minus n pi भी क्या होगा 0. Since n क्या होता है, it belongs from integer, so 1 minus n is also from integer, so it is also 0. So ये overall क्या हो जाएगा 0. This implies bn is equal to 0. Now there's one thing जो हमें पता करनी है कि अगर फंक्शन की वैल्यू 1 पर है, n is equal to 1 पर है, तो b1 क्या होगा, बिकॉज वो हम सीरीज एक्सपेंशन में यूज करेंगे. नाउ फाइंड b1. सिंस जो फंक्शन की वैल्यू bn 0 आई है, इट इज नॉट डिफाइंड फॉर n इज इक्वल टू 1. नाउ b नीड टू फाइंड इट फॉर n इज इक्वल टू 1. नाउ bn is given by 1 upon pi integration 0 to 2 pi f of x sin nx dx. So b1 कैसे होगा, b1 is equal to, it is equal to 1 upon pi integration 0 to 2 pi f of x, in place of n write 1, so it is sin x dx. Again इसको दो इंटरवल्स में लेना होगा, सिंस फंक्शन हमें दो इंटरवल्स में गिवन है, so it is 1 upon pi, that is b1 is equal to 1 upon pi integration 0 to pi f of x sin x dx and 1 upon pi integration pi to 2 pi f of x sin x dx. नाउ यहाँ पे फंक्शन की वैल्यू क्या है 0, तो ये वाला पूरा पार्ट हो जाएगा 0. सो क्या बचा, इट इज 1 upon pi integration 0 to pi f of x sin x dx. and f of x क्या था, it was sin x, it is sin x dx. so इसको क्या लिख सकते हैं, 1 upon pi integration 0 to pi sin square x dx. now to solve this हमें एक और ट्रिग्नोमेट्रिक आइडेंटिटी पता होनी चाहिए, that is cos 2x is equal to 1 minus 2 sin square x, जिसको sin square की x की फॉर्म में कन्वर्ट करेंगे, so it is 2 sin square x is equal to 1 minus cos 2x and sin square x is equal to 1 minus cos 2x divided by 2. so using this हम इस इंटीग्रेशन को सॉल्व करेंगे. this gives b1 is equal to 1 upon pi integration 0 to pi, put the value for sin square x, it is 1 minus cos 2x divided by 2 dx, जिसको सेपरेट करके लिख लेंगे, it is 1 upon pi integration 0 to pi 1 upon 2 dx, जिसमें हम क्या करते हैं 1 upon 2 को कॉमन ले लेते हैं पहले ही. so it is 1 upon 2 pi integration 0 to pi 1 dx minus integration 0 to pi cos 2x dx. now it is equal to 1 upon 2 pi integration of 1 dx is x, limit is from 0 to pi, minus integration of cos 2x is sin 2x divided by 2 and limit is from 0 to pi. now put the limit, it is equal to 1 upon 2 pi minus 0 minus sin 2 pi minus sin 0 in bracket whole divided by 2. Now since we know that sin n pi is equal to 0 for all integer n and sin 0 is also 0, so ये वाला पूरा पार्ट क्या हो जाएगा 0. so remaining is 1 upon 2 pi minus the whole part is 0. So it is pi divided by 2 pi. Pi se pi cancel, it is 1 upon 2. And this is the value for B1. Now, the Fourier series expansion will be, it is given by f of x is equal to a naught upon 2 plus summation n is equal to 1 to infinity an cos nx plus summation n from 1 to infinity bn sin nx. Now, इसको simplify करेंगे, it is a naught upon 2 plus a1 cos x plus a2 cos 2x plus a3 cos 3x and so on plus b1 sin x plus b2 sin 2x and so on. Now a naught and an की value क्या थी? The value of a naught was 2 upon pi and for an it is minus 1 raised to the power n plus 1 divided by pi in bracket 1 upon 1 minus n square. And a1 was 0. b1 was also 0. It is bn was 0 and b1 हमने find out करा था, it was 1 by 2. So using all this हम further simplify करके लिखेंगे Fourier series expansion. So a0 क्या था? It was 2 upon pi. an क्या था? It was minus 1 raised to the power n minus 1 divided by pi in bracket 1 upon 1 minus n square. bn was 0 and b1 is 1 by 2. So using all this हम ये लिख सकते हैं 2 upon 2 pi plus and a1 was also 0. So plus a1 cos x वाला part is 0 plus a2 and a3 से सारा part हो जाएगा summation n is equal to 2 to infinity, that is n from 2 to infinity an cos nx plus b1 क्या था? It was 1 upon 2 sin x and further b2 b3 till bn it was all 0. So आगे वाली terms क्या होंगी? 0. So ये हो जाएगा an was minus 1 raised to the power n plus 1. So नीचे plus आएगा जो हमने minus ले लिया था. Here it is plus. So an is minus 1 raised to the power n plus 1 divided by pi 1 upon 1 minus n square. So it is, इसमें 2 से 2 cancel हो जाएगा. So it is 1 upon pi plus summation n is equal to 2 to infinity. an is minus 1 raised to the power n plus 1 divided by pi in bracket 1 upon 1 minus n square cos nx plus 1 upon 2 sin x. So this is the final Fourier series expansion for the function fx. Now हमसे क्वेश्चन में पूछा है to make a summation series. उसके लिए so for that हमें function की value 0 पे लेंगे. We will solve this taking x is equal to 0. So f of 0 क्या होता है? Function की value was sin x in an interval 0 to pi and 0 in an interval pi to 2 pi. तो फंक्शन की वैल्यू थी sin x in an interval 0 to pi. So 0 पे फंक्शन की वैल्यू क्या होगी? It is sin 0 and sin 0 is 0. So फंक्शन की वैल्यू at 0 is 0. So it is 0 is equal to take x on both. Take x is equal to 0 on both sides. So it is 0 is equal to 1 upon pi plus summation n is equal to 2 to infinity. Taking n from 2 to infinity minus 1 raised to the power n plus 1 divided by pi 1 upon 1 minus n square cos nx x के place पे 0 तो it is cos 0 plus 1 upon 2 x के place पे 0 it is sin 0. Now cos 0 is 1 and sin 0 is 0. So ये हो जाएगा 1 upon pi plus summation n from 2 to infinity minus 1 raised to the power n plus 1 divided by pi in bracket 1 minus n square. This is 1 and this is 0, so it is plus 0. जिसको हम लिख सकते हैं 1/π minus 1/π is equal to take 1/π summation n from 2 to infinity, it is from 2 to infinity minus 1 raised to the power n plus 1 divided by, so it is minus pi divided by pi, ये यहाँ multiplication में चला जाएगा, it is summation n from 2 to infinity minus 1 raised to the power n plus 1 divided by 1 minus n square, which is equal to minus 1. Now इसको simplify करने के लिए observe that minus 1 raised to the power n plus 1 is equal to 0 when n is equal to odd. When n is an odd term, this will be 0. Since minus 1 raised to the power odd will be minus 1 plus 1, 0. So ये पूरा summation 0 हो जाएगा. So हमें ये सिर्फ even terms के लिए देखना है. So ये क्या होगा? minus 1 is equal to, for n is equal to 2, it is 2 upon 1 minus n square. For n is equal to 3, it is 0. For n is equal to 4, it is 1 plus 1 divided by 1 minus 4 square and so on. So ये क्या है? minus 1 is equal to 2. Since even terms ले रहे हैं 2 summation n from 2 to infinity and it is 1 upon 1 minus n square. So 1 minus n square को हम separate करके लिख सकते हैं, it is 2 summation n from 2 to infinity 1 upon 1 minus n and 1 plus n. So it is equal to minus 1 is equal to 2 summation n from 2 to infinity 1 upon, take minus common, minus 1 upon n minus 1 and n plus 1 form. Now minus से minus cancel, it is 1 upon 2 is equal to summation n from 2 to infinity 1 upon n minus 1 and n plus 1. Now open this up. This is equal to 1 upon 2 is equal to, put n is equal to 2, it is 1 upon 1 multiply n is equal to 2 plus 1 is 3 plus, put n is equal to 4, n is equal to 3, it is 3 minus 1. Since it is for even, so we will take n is equal to, okay. So जब हमने यहाँ पे से 2 कर लिया था, that is हमने already terms को even कर लिया था. So इसे simplify करने के लिए we can write n is from 2k and k is from 1, 2 and so on. Since जितनी n terms आएंगी ये even होनी चाहिए. So इसको हम और भी तरीके से लिख सकते हैं, that is summation n is from 2 to infinity 1 upon 1 minus 2n का whole square. Now अगर हम 2n ले रहे हैं n is equal to 1 पे हमारे पास क्या आएगा? 2. So n कहाँ से हो रहा है? It is already from 2 to infinity. So it is 1 minus 2n square. So ये जो भी है इस पे we can add 2. So finally it is 1 upon 2. 1 upon 2 is equal to summation n from 1 to infinity 1 upon 2n minus 1 and 2n plus 1. Now it is 1 upon 2 is equal to, take the value n1, then it is 1 upon 1 multiply 3 plus 1 upon, take the value 2, it is 4 minus 1 3 multiply 4 plus 1 5 plus 1 upon, take the value 3, it is 6 minus 1 is 5 multiply 2 3 6 plus 1 that is 7 and so on. And हमसे यही सीरीज पूछी थी to make. Series was this and हमसे यही पूछा था that is 1 upon 2 is equal to 1 upon 1 multiply 3 plus 1 upon 3 multiply 5 and so on. Hence it is done.